Thank you. Yassou Thessaloniki? Did I say that right? Yes. Okay, cool. So I will stop speaking Greek from now. I'm just going to speak English. My name is Abdel. I'm a cloud developer advocate at Google. My background is I have a master's degree in software engineering. I've never really worked as a software engineer, so I am a wannabe software engineer. But I spent most of my career doing ops stuff. These days, I work mostly on Kubernetes-related topics, but the topic of today is not Kubernetes. It's mostly about software supply chain security. By show of hand, oh, this is, OK. By show of hands, how many of you here consider themselves developers? How many of you are ops people? Operations, DevOps. How many of you are from security or do security? 2 people. OK, cool. All right, so let's see if this would make sense for you. I think if you're a developer, you know that building software is not easy. And the last couple of years have proved that it's actually becoming more and more complex to have secure software. For a very long time, those who want to attack you or hurt you, they will just try to do it in your production system. They will target your servers or your installation, your system. And as the industry have built up tools and systems and mechanisms to protect software when it's running in production, attackers now are trying to kind of find different ways to hurt you, right? And so these are just a couple of examples of this new type of attack that we call supply chain attacks. And I'm gonna explain later what supply chain means. SolarWinds, you probably heard about it. SolarWinds is a monitoring software that is used by other companies. And one of the biggest attacks last year was a company in the US called Continental Pipelines. So they are the company that runs the gas pipeline that supplies the entire east coast of America with gas. And the problem with this kind of attacks, new attacks, is that we see reflections or we see damage happening to actual people in real life. When the Continental Pipeline got attacked through SolarWinds, the effect was that there was lines in gas stations because people were freaking out, thinking that the gas stations will run out of gas because there is no more gas, right? But there is one that happened actually in Europe very recently. It happened in Sweden. I live in Sweden, in Stockholm. We have a big supermarket chain called Coop. And last year, they had to close roughly all their stores, about 700 stores, for roughly 24 hours. And the reason they did that is because Coop uses a third-party company. They outsource to this company the management of their checkout booths. It's the place where you buy your groceries and you go scan them yourself and you pay and you leave the store. And that company uses a third-party software called Kaseya. So Kaseya was attacked by a software supply chain attack. And they created a patch that they sent to their customer, which is the third-party company. And that third-party company installed this patch in Coop's systems. And they ended up with having a backdoor in their system for 2 months that was basically leaking a lot of customer data. And so this illustration is just to show that with software supply chain attacks, you can basically target one specific library or one specific dependency or one specific piece of software that everybody uses, and then you can get a ballooning effect because everybody uses that. Another example very quickly before I move on. If you have a Mac, you're probably familiar with Homebrew, right? Homebrew is what you use to install things. A few years ago, somebody actually demonstrated that they were able to gain committer access to Homebrew GitHub repository, and that GitHub repository did not have master branch protection or main branch protection. So if you get committer access, you can just commit code. You don't need the pull request, right? But they demonstrated that this is possible, that this kind of new attacks are possible. And that's because the way we build software is inherently complex. No one today is actually writing most of the software or most of the code. You are mostly depending on other people, third-party libraries, and you are building code that is relevant to your business. And then you just have a magical system in the middle called the build system, which builds this stuff, packages, and send it to production. But what we don't really realize is that even your dependencies are actually probably built the same way. Even your dependencies follow the same concept. They rely on somebody else's code. They build their own little magic. They put it through a build system, and then they release the dependency. And actually, what you see in front of you is what we call supply chain, software supply chain. Basically, it's just a fancy term to say CI/CD, right? And the whole point of security around the supply chain is because a supply chain is inherently vulnerable to a lot of attacks. or a lot of attack vectors. In the security space, when we are trying to protect something, the first term we ask ourselves is what's the potential attack vector? And then once you have the attack vector, then you have the steps an attacker would use to infiltrate that system, and then you can secure it. So you can start with like bad code, just downloading a bunch of vulnerabilities from the internet that you don't know. Your code or your source system could be compromised. You leak your SSH keys to GitHub, or you put them in a like a public space, or stuff can happen. There was actually a very interesting article I read yesterday from Aqua Security. It's a company that does cloud native security. They did some research and they realized they could actually find on GitHub alone something around 800 leaked secrets from Docker. These are mostly coming from Kubernetes, so people committing Kubernetes configuration to GitHub, and they found like SSH keys for GitHub repositories and a bunch of things. And most of those are coming from build systems that are designed to run on top of Kubernetes. So things like Argo CD, if you're familiar with Argo CD, if you use Argo CD on Kubernetes, you need to give Argo CD the SSH keys so it can monitor your Git repository. So when you do code changes, it will build your system, right? So they managed to find a bunch of secrets on GitHub, which is not good. You can have like a compromised build system. One of my favorite examples is last year over Christmas. There is a company that does manage CI called Circle CI. I don't know if you're familiar. Has somebody who uses Circle CI here? What, 2 people? Okay. I hope you were not hacked. Because last year, actually, they didn't leak their customers' keys. They leaked their own keys. They leaked their own AWS keys on GitHub. And they didn't realize for like 2 weeks. And then when they realized, they just went back and asked their customers to please rotate all your keys. And then, a lot of things can go wrong, essentially. That's what this picture is trying to show. So how do we solve this? So in the wake of the realization of these kind of attacks, a lot of efforts have been, like efforts as in projects and frameworks, started to like emerge to try to solve the software supply chain problem. And they are mostly focused around doing 2 things. Establishing trust by doing zero trust, and shifting left. So let's start with establishing trust. Establishing trust is very simple. It's essentially realizing this entire supply chain system that I showed, which starts from source code in some Git repository to the build system, to the delivery system, etc. Because we are mostly using third-party tool and we're composing them to get like a functioning CI/CD system, you inherently do not have a way to trust if a software moved from one step to another, if it actually came from trusted sources. And so zero trust essentially means having a way to verify the identity or the origin of software as it moves through the entire CI/CD system. And I'm going to show an example later. And shift left is essentially the idea of shifting the security responsibilities back to developers. Shift left is not new. It's coming from DevOps. That's the whole point of DevOps, is shifting operations left to developers. I don't like really the idea of shift left because it makes it look like now we want developers to be full stack engineers, which no one is. So the idea actually of shift left is making developers aware of what they're doing, giving them ways to scan the code, giving them ways to look at vulnerabilities, etc., etc. A project called SigStore got started a few years ago. So SigStore is a collaboration between multiple companies. It is under the leadership of something called the OpenSSF, the Open Software Security Foundation, which is an open source foundation, a nonprofit. And then it has a bunch of companies involved. And all these companies, they contribute code, they contribute frameworks, they contribute their own methodologies for software supply chain security. So SigStore has a lot of components. Some of them are actually software that you can use. Some of them are just like managed platforms. I'm going to mention just 2, which are very interesting to look at. There is a tool called Cosign. It's the one on the top left corner. So Cosign is a command line tool for signing and verifying the signature of container images. So if you build container images and your images are OCI compliant, which most container images are, OCI means the Open Container Initiative, which is the standard, essentially, that mostly Docker builds toward. You can use Cosign with a key to sign the image and attach the signature to the image as metadata, and then so that down the line in your CI/CD pipeline, you can also use, again, Cosign to verify the signature of the image. They also have something called GitSign, which essentially does the same thing for Git commits. So if you have like when you're committing code, you can commit code with your own identity, and then you can use a third-party IDP, identity platform, to sign your code, like Google or Facebook or Microsoft or whatever. And then they have something called Rekor. So Rekor is a public ledger. Recore is both a software and a public ledger. There is actually a public instance that is already there. You can just go to recore.chainguard.dev, and then you can look in Recore to find if some libraries you're using have been signed using cosign or using one of these tools. You can also look at the Git signature. You can look at a bunch of things there. And it's also software, so if you want to have your own version, private version of Recore for your own company, you can just use Recore to run the ledger. So this is how SigStor supply chain security looks like. Basically, as a developer, I get a certificate from somewhere. You can use your own certificate system or your own PKI, public key infrastructure, or you can use Fiducio, which is just a certificate authority. You get a certificate, and then you use that certificate to sign an artifact. So an artifact could be a library, could be an image, could be whatever. And then you publish both the artifact and the signature, but you also add to Recore a log that says, I, person X, have signed this Git commit or this artifact, and this is the proof that I have signed it. This is something we call in security an attestation. Then as an end user, I am able to either use the Recore transparency log to check the signature of that particular artifact I'm interested in, or I can actually download the artifact and then download the key and then use the key to verify the signature myself. So this, in a nutshell, what this is all about is, you know, today when you go to like some website to download a binary, you can also download a SHA-256 signature of that binary or an MD5 sum, and then you can use a command line to verify if this binary meets this signature. This is the same exact concept, except it's using more fancy tools like asymmetric key cryptography. Then they have a couple of frameworks. One of them is called SLSA. So SLSA stands for Security Levels of Software Artifact. It's literally a checklist system, which is basically looks at the entire supply chain and looks at each step of this supply chain and provide you with guidance for how to secure it. So if you look at SLSA level, I'm not going to go into the details, but if you look at level 3, you have to have version control, you have to have verified history. So verified history means signed Git commits. You have to retain the history for 8 months. You have to have a scripted build system, ephemeral build system, etc., etc. If your entire source code, build system, and deployment system meets those requirements, it means it's compliant with SLSA level 3. And the last piece in this entire puzzle is something called SBOM, the software bill of material. I have a very, very dumb way to explain SBOM, and I'm not explaining this way because I'm considering you kids. I'm just explaining it in an easy way. Picture your favorite dish, your favorite Greek dish, moussaka. You want to make moussaka, you need ingredients and you need a recipe, right? The recipe is the steps you're gonna follow to build the dish. That's probably something that you got from your grandmother. And then you have the ingredients. So in software world, the ingredients are the libraries. And that's what SBOM tries to solve. In software world, an SBOM is essentially the list of libraries that have been used to build a particular artifact. And this SBOM is basically a text file, which comes in either SPDX or CycloneDX format, just like basically like YAML or JSON, just a specific format. And then you take this text file and then you add it as metadata to the artifact so that later down the line, you have a proof or you have a list of all the libraries that have been used to build that artifact. Not only the libraries, you have the libraries where they came from, the Git repository they came from, the license under which that library have been released, etc., etc. So these two things, or these three things, so basically SLSA, SBOM, and everything that SigStor have built are not components that you have to use entirely. Security is a multi-approach layer. Securing any systems starts by just building one layer at a time and adding things as you go along. I'm a big advocate for what I call incremental security. So the whole point of all these systems is that you start adopting them one component at a time in your system until you get to a point where you have something relatively safe. By the way, before I move on, because we are all in the European Union, in 2025, there is a law in the EU that will go into effect called NIST2, N-I-S-T2, which will force certain companies in certain sectors to generate and store SBOM and be able to provide SBOM if they are asked by the regulators. And certain industries, I mean healthcare, finance, the insurance world, transportation, and a bunch of other energy, etc., etc. So this is going to be actually becoming important in the future. And with that, that's it. Thank you very much. I hope it made sense.